Today's notes are about physical science, CPO textbook 10.3, The Phases of Matter, and also Study Island, States of Matter. Both of these topics are very similar, so I combined the two of them into one lesson for you guys. At the top of my notes, I have my name, I have the date that they were taken, and my homeroom section. So I am the homeroom teacher for 6D. I put 6D right there. And this is for science. So if you are in 6A, 6B, 6C, or 6D, you'll put your homeroom accordingly. I start my Cornell notes with physical science and my topic that these notes are about. First, we're going to start with some vocabulary. Number 1, particle. A particle is a tiny amount or a small piece, speck or a trace. So it's like something really small. It's normally something that we can't even really see with our bare eyes. Physical property, number 2. A physical property is something that can be observed with the 5 senses, like a color, a shape, melting, freezing, or boiling point. Is it a solid, a liquid, or a gas? What does it smell like? What does it feel like? What does it taste like? Those are physical properties. Number 3, phases of matter. So on Earth, most pure substances can be found as a solid. For example, that would be like a rock. This piece of lepidolite is actually a bunch of pieces of lepidolite. It is a rock. It is a bunch of solids. Matter can exist as a liquid, such as water. So in this bottle right here, I have water. That is a liquid. Substances can also exist as a gas. That's like the air. So, like, move your hands around, you can feel the air. That is a gas around you. These are the states of matter: solid, liquid, and gas. Number 4, solid. Solid is a phase of matter that holds its shape and does not flow. Liquid. Liquid is a phase of matter that holds its volume but does not hold its shape, and it flows. Gas. Gas is a phase of matter that flows, does not hold its volume or shape, and can expand, get bigger, or contract, get smaller, to fill a container. Intermolecular forces. So number 7 is intermolecular forces. They are forces which are pushes and pulls between atoms or molecules in a substance that determine the phase of matter. So if you have strong intermolecular forces, they're going to be pulling all the particles really super close together, really tightly packed. It's going to be a solid. If those intermolecular forces, those forces in between molecules, if those are a little weaker, it's going to be a liquid. If they're not very strong, maybe they're repelling each other, it's going to be a gas. Number 8, melting point or freezing point. This is the temperature at which a substance, a thing, changes from solid to liquid, which is melting, or from a liquid to a solid. That's called freezing. Number 9, boiling point. The temperature at which a substance changes from liquid to gas, that's called boiling, or from a gas to liquid, that's condensation. And last definition, number 10, plasma. Plasma is a phase of matter heated to such a high temperature that some atoms break apart An example of that is the sun or any of the stars. There are a lot of stars in the universe and nebulas and all sorts of things like that. Plasma is actually the most common state of matter in the entire universe. On Earth, not so much, but in the whole wide universe, plasma is the most common. Okay, so the phases of matter. Again, those are solid, liquid, gas, and plasma. On Earth, most matter is found in the three phases: solid, liquid, and gas. The state of matter depends on how the particles of a substance move and the distance between them. So this table right here kind of goes over how you would classify each of these different states of matter. So a solid would have very little movement. The particles would be very close together. If I compare the temperature of a solid, liquid, gas, or plasma of the same substance, the same element, the same thing, a solid is going to be the coldest. It's not always going to be cold, but it's going to be the coldest compared to its liquid, gas, or plasma form. Its volume is constant. Its shape is constant. That means they don't change. It does not flow. And a solid, its particles might be packed very closely together, kind of like this. For a liquid, there will be some movement. The particles will be close together. Its relative temperature is going to be cool. So it's not as cold as the solid, but it's definitely not as hot as a gas or plasma of the same material. Its volume is constant. It's going to stay the same amount of space that it takes up, but its shape can change. And yes, it can flow. So a liquid, its particles, they'll be close together, but they're not going to be quite as organized as that solid. It's like a liquid right here. If I measured out this liquid, I would be able to measure out a certain number of milliliters or cups, and that's going to stay the same. But as I move the bottle here, it's changing shape. And if I were to pour this out into a glass, it's going to take the shape of whatever I pour it into. So its volume is constant, but its shape will change. Gases, they move a lot. The distance between the particles, they are far apart. That's how they can move. Its relative temperature is going to be hot. Its volume can change, its shape can change, and it definitely flows. So its particles might look something like this. If we think of ice, water, and steam, ice is cold. Water is, like it's about average temperature, and steam is hot. So think about ice cubes, water, and steam, and you'll have a good idea about solid, liquids, and gases. Plasma state, it has the most movement. The particles are the farthest apart. It is relatively the hottest because it has been heated well beyond the gas state. Its volume will change, its shape will change, and yes, it flows. So plasma is like the bestest. Alright, changes of state. Changing the amount of thermal energy a substance contains changes the motion and arrangement of its particles. This can cause a change of state. So I put this into what I feel like is maybe a little easier to understand words. My Riggle translation is that by adding or removing heat, you can change the state of matter. So adding heat, think of putting a pot of water on the stove. You're adding heat to it. You're making it hotter. So you can melt ice, turn it into water. You can take water, turn it into steam by doing that. Removing heat, that's like when you put stuff in the fridge or in the freezer. you're taking the heat away from it. You're stealing that heat. You're removing the heat. And you can turn water into ice. You can turn liquids into solids. You can turn steam into liquid. So melting and freezing. We all know about ice. You take it out of the freezer, and within a few minutes here in either Phoenix or Tucson, wherever you live, if it's not wintertime, it's going to melt pretty quick and turn into water. We are so familiar with this one because it is always so toasty hot here. So adding heat energy to a solid can make it melt. So if we started out with a solid like this, where it's just maybe an ice cube in a bowl, in a glass or something, it's just sitting there, minding its own business. It gets heated up, and then all of a sudden it melts, and now it starts to take up the size of the container. Something like lava. That is liquid melted rocks. It starts out super hot. And so all that melted rock, all that lava, as it cools down, even if it's not like what we would call freezing cold, it doesn't feel like an ice cube, it can be room temperature, it's going to turn into a rock. When that lava turns into a solid, it goes from a liquid to a solid, it just froze. So liquid to solid is called freezing, no matter what temperature it's at. And so this example right here, this would be like one of those Hawaiian volcanoes, and this might be maybe some basalt lava. When it freezes, it turns into olivine and basalt and gabbro and all sorts of really cool, very iron-rich rocks. Hashtag geology nerd. Removing heat energy from a liquid can make it freeze. So basically, the lava came out of this volcano here. It got exposed to the super cold air, or the, normal Earth temperature air, not inside the Earth, but outside the Earth temperatures, which is relatively cold. And so the heat comes off of the lava, and it goes out into the world. So it's losing heat. It's removing the heat energy. That loss of heat energy causes it to freeze. So here's my liquid right here. It's losing heat to the world, to the environment, and it turns into a solid chunk. All right, so evaporation and condensation is the next one. If we take a pot of water, put it on the stove again, it's going to start to boil. You're going to get some steam coming up off of it. So adding heat to a liquid can make it evaporate. The word is evaporate. So we're starting out with our particles. They're, kind of close together. They're a fixed volume here, and they're taking up the shape of our container. But when I add some heat to it, they're going to start like bouncing around like crazy people. Like they need to calm down. But they're like particles all over the place. That's going to be turning from a liquid to a gas by evaporation or evaporating. The other example, the backwards way, is condensation. So if you have a glass of cold water, maybe you've got some ice cubes in there, it's really cold. And then you feel the glass a little bit later and it's wet on the outside. But it's not because your glass has a crack in it. It's not because your glass is leaking or anything. It's because the water vapor in the air, the steam in the air, it finds your glass and it's like, ooh, that glass is cold. I like that. And it attaches itself to the glass and it goes from a gas down into a liquid. Another example of that is if you breathe onto a cold window when it's cold outside and warm inside your house. Breathe onto that window. You might be able to do it right now today. Breathe on the window. You're going to see like it's going to fog up. I know you've done this before. Come on, people. You make it fog up. You draw a little happy face in there or you write something. We've all done it. It's super cool. I still do it. I'm an adult, okay? That's condensation. When the vapors from your mouth, from your breath, it hits the window, it condenses. It turns from a gas to a liquid, and it looks like fog. If you take a hot shower, then sometimes the steam from your shower, it's going to get on the mirror and fog up your mirrors. That is condensation, because the steam from the shower, from the hot water, it hits the mirror's colder, it turns back into a liquid again. Sometimes you'll even get like dripping on the walls and on the showers if you took an extra super toasty shower. So removing heat from a gas can make it condense. So like when the outside of a cold glass gets wet from the water vapor. So pressure and phase changes. Increasing or decreasing pressure can change the state of matter. Pressure is caused by the surrounding air pushing on a substance. It could also be like if we're talking about our rocks example here. So if this were to form underground, we might have the weight of the whole entire world crushing down on that rock. And that can cause different phases of matter to form. So it can either cause it to melt into lava or it can turn it into a solid. So pressure, we're going to just say it's caused by the surrounding air pushing on a substance. It could also be from something actually physically touching it and pressing down on it. So if you think of it like squeezing something, if you squeeze a water balloon or like a handful of slime, you are adding pressure. So when you're squeezing, you're adding pressure. When you let go, you remove the pressure. So when you let it go, you remove pressure. With enough pressure change, the state can also change. So just like squeezing slime, squeezing a water balloon, you're not really going to do much. But if there is a very serious pressure change, like if we're talking about going underground and actually the earth crushing something, that's definitely going to be able to cause some state changes. If you have like a tank of compressed natural gas, that would be gas when it is out in the world, but when we pressurize it, put it into the tank, it turns actually into a liquid. So right here I have an example of just a big container. There's some particles in it of gas. If there's very low pressure applied, the particles can move easily. It's going to be in its gaseous state for this example. If I add enough pressure, so like a medium amount of pressure, the particles are forced closer together, and it's going to turn itself into a liquid. At a higher pressure, so if I add even more force to it, even more pressure, I squeeze it even harder, then the particles are forced the closest, and it will turn into a solid. So now that you've taken all these notes, hopefully you understand them a little better if you listen to me talk to you about them. You're going to write your own summary. It should be at least 2 or 3 sentences about the notes. You can make it longer than this, but do not make it shorter. 2 sentences, that's not very much. Tell me what you learned about. Was there something brand new that you never knew about? Did you know that pressure could cause changes of states of matter? If not, put that in your summary. Did you know already that solid, liquid, and gas were the main phases on Earth? Maybe you did. Maybe it's worth mentioning it again in your summary, that the main phases of matter on Earth are solid, liquid, and gas. They can be changed based on the temperature and based on pressure. Adding more pressure will make something go more toward a solid. Removing pressure can help it become a gas. So come up with your own summary, write something in there, get yourself some good points. This is a super easy A, and you're going to do some Study Island on this as well, and I'll be able to answer questions in Zoom on Thursday. So see you guys later and have a great day.